begin the panel discussion. This will be a 30-minute session in which we'll have all the three speakers sat over here, and we'll run by them between 3 and 5 questions, and they will share their thoughts on those questions. So if you could, if the three speakers could please move to the podium. The first question is, what is the biggest change you have seen in your work and career over the last 3 years?
So again, in the last 5 years, we're increasing the application of machine learning. In fact, the algorithm that we have nowadays, and the amount of data that we have nowadays, made it possible to have this boost in the usage of it. So, from this perspective, that is the biggest change that I see. The actual problem resolution of business statements by applying that.
Of course, I got old. That was the biggest change that happened in the last 5 years. But one of the things that I've kind of learned is managing smarter people than me. It is amazing how people get smarter by every batch that we hire. And the other thing that I've learned on top of it is managing millennials. I think it is a different work ethic altogether. Millennials are smarter, but more difficult to manage. And I kind of, you guys surprise me every year. So yeah, that's what I've learned.
I guess it was quite a bit of a challenge to see the current crop of folks doing computer science or data science not really understand the nitty-gritties of what actually needs to happen. Because in many cases, like Abhishek was saying, most of these are modularized and packaged. So increasingly, I think the kind of population or the pool that's available for companies like us to hire from, we're seeing that a lot of fundamentals are actually missing. And that's a surprising thing from a change perspective. In the last 5 years, definitely.
In the domain of fintech, what are the typical career paths that most data science professionals could look into or could apply to?
So there are 3 paths actually that we have, 3 careers that we have. One is a computer vision career, because India is still a document-heavy country with not a lot of machine-readable data available at a click. So computer vision is one career. Second is having the combination of business understanding and the ability to use tools like R or Python to do analysis, where you don't have to go to the extreme of machine learning or AI, but you can use basic you can draw insights out of data, and to be able to use any tools except SAS, any tool that is available, which can help you become good at a job. And the third is visualization, where we want people to interact with audience who can create consumable layers of analytics. So it's great to generate good insights, but it's also equally imperative that you can convey that to a larger audience. And so visualization is the third track that we have. So it's basically reporting and visualization, insights, and kind of more descriptive analytics, and then computer vision or more AI type techniques.
I think the only thing that I would add to what my colleague in here mentioned is the NLP, natural language processing. I think there is a lot of unstructured data that needs to be analyzed, and if you're thinking about understanding the customers, that play a big role to analyze the sentiments and try to from a conversation that the customer had with the call center to understand what the real problem there, the real problem are, and how can we tap into that.
So following up on the question of careers, what should a budding data scientist have in him or her that would make them attractive to startups, MNCs, or any other kind of businesses?
I think that besides the knowledge in itself of data science, statistics or machine learning, I think one of the main important ingredients there is curiosity. It's being always curious about the data, not accept what is in there at the first glance, but dig deeper. What else can we have there, or which different use can I do with the data that I have? Ask the question itself. I think that curiosity is one of the greatest ingredient, because once you have that, expertise, knowledge you can acquire. But that characteristic is much more difficult for you to develop.
I have this checklist on people who I hire, and there are 3 things we look for. Have you participated in a cattle competition? What was your rank? Then, do you have a GitHub profile? And do you have codes on there which I can check? And third is, do you know more than 1 coding languages? And if you don't fit in any one of the 3, we don't even interview. So, and coupled with things like curiosity at the later stage. But if you're a data scientist who's looking to get into a career with coding and using different algorithms, then you should have some experience. And today, colleges provide a great platform, and there are organizations like GreyAtom, and you could go anywhere, but effectively, you need to have demonstrated an ability to show curiosity and ability to learn over the last few years of your career, of your education or career or whatever it is.
I would say the opposite of what I pointed out earlier, which is, the foundations matter a lot more. What is applicable in a particular situation is a lot more important than, the libraries you use or the coding languages, frankly speaking. So I think the initial gate would be something similar to what Abhishek said, but then you have to get past the initial gate and all the other gates that happen afterwards as well, right? I think the foundational layers don't get emphasized enough in almost any courses that we've seen get popularly taught and get adopted by people. So that's something that has to be, somebody has to address that problem.
This might be a bit of an exciting question. What are the things that you hate the most and enjoy the most about your respective jobs?
Yeah, I have a very specific answer for what I hate the most. Most enterprises have an established vendor list. It's so hard to get in as a startup. That's what I hate the most. But what I love the most is the fact that most companies nowadays are actually waking up to not being secretive about what they do with respect to data science. Earlier it used to be the case that it was either the upper echelons of the pyramid, they kept things to themselves and very rarely shared things out. But nowadays it's so vastly available, there's an openness, there's a transparency, and there's also this willingness to actually share, which is fantastic.
Data scientists are basically the cool guys on the floor. So I enjoy being one of them. And so the thing I enjoy the most really is the fact that this community can create stuff. This community can solve problems that nobody else can. And enjoying that ability, and of course doing justice to it, is the fact that kind of keeps me back to work every day. And the thing I hate the most is, while this has been the #1 kind of career that has been kind of touted across multiple forums, it is extremely difficult to find good data scientists. And I kind of quote the word good because you will find a lot of data scientists. But good data scientists are difficult to find because of the things that was mentioned, like creativity, curiosity, ability to actually challenge yourself rather than getting stuck into a language. So yeah, that's what.
It's a relatively difficult question, in fact, think about that. But I think one of the things that's definitely, especially I come from a startup background and work in a big corporation is challenging. As specifically, thinking of a big corporation as being a nation where you have a democratic system in place, and for you to execute any change, you needed to go through that democratic process of the people agree and voting and adopting and working on top of nowadays. And so making changes difficult. It makes the adoption of especially technologies like in AI that is, or you jumping on the train wagon now or you're gonna lose it in terms of competitive advantage, because your competitor may adopt that and change much quicker than you. Then you're gonna profit on top of that in the early adoption. So this is one difficult aspect that makes the certain aspects of law hate the side. But in the other aspect, the let's say the love side of my job, and it is the challenging projects that we have to tap in, and how that can impact people's life and can improve people's life. That is something very exciting, especially when you see the huge amount of data that bank can have there. It's amazing the amount of data to have that you can tap and it can impact positively people's life.
Now we're going to go into the most exciting part of the session, Q&A from members of audience. So some ground rules before we begin. State your name at the start of the question and keep your question limited to one sentence. And it's best if you could direct it to one of the speakers. You could say this question is for such and such speaker. You have their names up there. Or if you want to direct it to all of them, you can say to all of them.
So this is particularly to Abhishek. I think as much as I enjoyed your presentation, I was a bit scared, particularly downloading your application, knowing what it can get from my sort of mobile phone. But having listened to your conversation, definitely I can relate to it in terms saying all these data points that you want to collect is first very ambitious as well as very useful in terms of what you want to do. But going to the ethical question of this, right? So, and there are a lot of discussions in the current context that go behind this scene. How do you protect yourself as a company?
So when you say ethical, what do you mean?
So I mean, it's very hard to put aside rules in saying I just want to have the non-personal SMS versus the personal SMSs. Mm-hmm. And it's very hard to say I am not listening to a particular app, but I am listening to this app only. So
your question of being ethical is around the fact that did I tell you what I'm taking, first of all?
Yes.
And secondly, did I take anything that I should not have?
Yes.
Right? Part of it is consent layer. I mean, if you look at GDPR, if you look at Aadhaar ecosystem, everything works on a consent layer. So a user gives consent to do something, first of all. So if you can download our app, say no, and still get a loan. So you have the choice. The second part is, could we take something, for example, SMS is only a bucket in Android and you would not know whether I'm taking personal or other messages. Now that is something where we're building an organization, so a one failed trust factor could actually ruin the organization, so we won't do that. There is no way to prove it on the court right now, but that's something that every organization will have to take care of, that you're not taking something that you should not. Having said that, what I told you was about the fact that you could get that from the information. What I didn't say was we don't take it out of the app. So our app crunches all the data within the app and takes those insights. So we don't take the data to our servers, we keep it within the app.
Okay, I think fair enough. So in the other context of the same set of informations you are trying, all of these informations at times also as a machine learning practitioner, we know create a certain kind of a bias. I think some of the audiences were also asking the same question, whether if you use this, is it more causal understanding or it's just a sort of some correlation that you're trying to draw, right? And that might actually impact to a large extent what you infer from the models you are trying to build. So how do you handle that part of it?
Our models are not perfect. So they are going to be perfect in the next 5 years. But they're not perfect today, which means we are going to lend to bad guys and not lend to good guys. Most likely we are not going to lend to good guys in the absence of information. So the bias typically is in the absence of data. Where there is data, there are factors both positive and negative, and you can figure out whether you want to take that risk or not. But where there is no data, you choose other data sources to approve or reject, and that is where you might have a case where you should have approved, but in the absence of data, you did not. But that is the reality of the market today. 90% of Indian SMEs don't get loans because of that. With our models, probably 50% will not get, but remaining 40% will get. So it's a journey. As digital footprints increase, as data sources increase, this problem will get solved.
Hi, I'm Pragya. So a lot of our data, real life data, is unsupervised. So while practicing data science, the problem I face is we take data, we model them into clusters, and we try to get insights from that. So this question is to all of you. So what is the best way, according to you, to validate what we are doing? Like, because as the data is unsupervised, we do not know the final clusters or the definite things to like what is this can be. Like, there are no definite rules. So how do you think the best way is to validate that?
I don't think there is a definitive methodology as such for validating, but then again, I think the question to really ask is, there is a top level problem you're looking to solve, and that problem breaks down into these models that you're building. So being able to explain that problem in a way that satisfies you is, I guess, the first step of validation. But then the next step is whether that explanation itself is correct or wrong. And for that you would need some amount of labeling in certain contexts. Like for instance, you could do sampled supervised as an example. That could be one, it depends on the problem of course. I think then, even if that doesn't work or that's not sufficient, at some level you will have to do field experiments also in order to validate your hypotheses. Yeah, I guess that's what I would say.
I would agree with Ragan at a certain point, and interestingly, that is exactly where Richard Searcher, this is a professor at Stanford, is teaching deep learning. His approach is exactly that. He used to recommend the time that you're going to spend trying to figure out, when a problem with unsupervised learning, it's much easier for you to label the data and apply unsupervised learning on that. So obviously, everything, in machine learning, as I mentioned before, is a very exploratory kind of solution. Okay, so you don't have a single recipe that applies to everything. You need to analyze a problem to problem. But I do believe that in having this approach of labeling your data and trying to solve a problem which is supervised will be much easier at the end than trying to solve it using unsupervised method. But it doesn't mean that you wouldn't explore. Again, it's really a case of a problem, exploring, trying, and seeing what the data is telling to you.
Yeah, so my name is Shikhar, and I wanted to ask the three of you, what is the scope of transfer learning? Since we all always moan about how we spend 60 to 80% of our time processing the data, and data is not standardized everywhere. So if you want to use something like a pre-trained ML API for whatever task, let's say for a classification or a regressional problem, so what would be the best approach towards this problem?
Transfer learning, it's applied much more within deep learning method. You can reuse some, rarely, in fact, I've seen you reusing, let's say, more traditional machine learning models, applying to different problems, as you mentioned. We need to think that machine learning, its models is very dependent on the data that you prepare. That's why we spend, up to 8% or even maybe even more. I'm not sure if someone really measured that, but it's 8% of the time, working on the data, preparing the data, choosing the right features that you're gonna use in a model. To running the model, choosing a model and running it, once your data is ready, it's like that, But getting the data right, choosing the right set of features, engineering new features, that is the hardest part. So, said that, apart, traditional machine learning models, that I haven't ever applied before. Transfer learning applied a lot in deep learning, specifically, dealing with images, because it's relatively common. I want to classify these type of images. My convolutional neural network, you're gonna, run and create and identify different features within the data and extract those. So I can reuse up to part of that set, and retrain only the last or the fully connected layer, because I wanted to classify, let's say 3 different type of images where, my model that I'm using has been trained to identify 1,000 different images and has been trained on millions of images which I do not have. So those are the cases that I have been used, and I have seen the use of transfer learning. Besides that, I haven't seen.
2 things I want to say. One is an example, and the other is a related concept. So the example is using transfer learning. There was a problem of automation of detection of defects on in assembly line, and I think we were able to do the entire project in 5 weeks. Completely unheard of in that setting. If you were to actually, and if you were to approach it from scratch, it would have taken eons of time. I think there's tremendous scope for applying this. But then, as with all these kinds of techniques, you have to be careful about where you apply. The other thing I wanted to mention is most of these cloud providers nowadays are exposing what I would call as ready-made APIs, which actually embed transfer learning internally. So even if you didn't know much about it, you could still apply in many different contexts. I think there's one entire stream of work called AutoML. You should look it up. It's fantastic in its capability. So multiple different applications of this, and many of these cloud providers have it now. So it makes it practical, is what I'm trying to say.
My name is Mayur, and my question is for all of you. So the thing is, machine learning has been successfully applied in field for images and text. So can you talk a bit about like how do you go about applying machine learning for videos? Because machine learning depends entirely upon how it is processed, how it is put into the model. So can you talk a bit about like how do you process the video data and make a model out of it?
Yeah. So the first step in almost any of these exercises is to actually construct a structured data representation. So for video data as well, there are a bunch of different ways in which you can construct a structured data representation. The first thing that you would do is look at the bit rate, look at the frame rate, and each frame by itself it's basically a series of images. So understanding what's happening in a frame allows you to actually extend what's going to happen 20 frames or 40 frames from now, based on the nature of the video that you actually generate. And the other part is there are features which are embedded across frames, which, for instance, motion, right? And that is something that's ultimately again structured data representation. So if you think in terms of data preparation to create these structured features, you're looking at it as a sequence of images, and then there are few features which are across images. That's the simplest way to break it down.
Hello. Yeah. Abhishek, I want to ask you that as you mentioned that you use email address and you decide that if email address has some particular keywords, then it can tell us about whether that person is good or not, give a loan. But how do you decide that without having any training data? Or do you have any training data?
We do have training data. I mean, we've been giving loans for the last 2.5 years.
Okay,
So,
but when you started, you didn't have.
Yeah, of course.
So
I keep saying this, our cost of learning is our failure. Because when we give a bad loan, that becomes the one in your record, and then you start training on that one, and eventually you have more ones, and you pray that you don't have more ones, because when you get more ones, you start training more. So yes, but there are different ways to actually acquire data. So it's not that on day one we did not have any model, but we can talk about it offline, but there are different ways in which you can acquire data to train your models in the first place, but they of course get more and more intelligent over time.
are there any other standard ways to give credit score without any training data? Suppose you have data about your customers, but you don't have training data. You cannot tell whether this segment is good or this segment is not good.
Typically, primary research. I mean, you could actually do some research to. So there are only two ways really. I mean, which we've tried. One is finding surrogate data. So while you do not have whether the person took a loan and defaulted on the loan, but there are other factors that you can use as a surrogate to display the same behavior. So for example, in this case, you maxed out your credit card. Okay, so if you maxed out your credit card, which would mean that you were actually stressed for your finances, and if you had taken a loan, you would have defaulted. So it's kind of a surrogate variable. So I'm giving you an example, but there are various other ways in which you can identify whether you can use that as a variable or not. So that is one, and second is research, where you collect data yourself in the first place.
Thank you. Last question for network.
Hello. My question is for Abhishek. Abhishek, have you done any analysis of the quality of your rejection? For example, I mean, first of all, is it possible? Secondly, the meaning of quality of rejection is that somebody you rejected, that person went to someone else and got a loan, and it was actually not a bad customer.
In fact, we have a set of people who actually do that on a daily basis. So everyone that we reject, we actually track them through a primary survey or through other methods to find if they've been given a loan elsewhere, and then we find out that how did they trend over time, and then feed that back into the model. But those are more subjective learnings rather than a machine learning model. So these are more because, for example, we may have a policy that we would not give money to a certain sector, let's say steel. Anybody who trades in steel, we won't, because we think steel is volatile. But then effectively we would have 100 loans that we rejected, and then we would track them and see, okay, 20 of them got a loan elsewhere, and we would try to find out what was different in those 20 where they got a loan and did not default, and arrive at a learning, for example, that there are within a sector there are good people and bad people. So good people may have had a good repayment track record in the past because of the loans, so they've always taken loans but never defaulted. So irrespective of the sector, there are people who know how to manage their finances. So that is, so there are only two things that, I mean, effectively, apart from efficiency and everything else that the data science team does, is about not letting good people go and not letting bad people in. And those are the groups of people that would look at this exercise.
First of all, what a pleasure this has been. I mean, for me, I've immensely enjoyed this experience of being at this, one of its kind, after I moved back to India, this is a really high quality event conducted by everybody. So, just a few words about me. So I have the pleasure of leading the machine learning team for ISAC here in India. And we started with about 4 people about a year ago, and now we are over about 25 people. So that speaks a lot about the growth trajectory for the team as well as this field of data science. Like Isaac said, we are growing and we would love to talk to you after this event. So please do come and talk to us. We heard a lot of interesting ideas today, and I'm definitely going to read more about things like data natives. I think that was really interesting. Also, I second Abhishek's comment about millennials and managing millennials. I guess I'm having my own experience with that, positive and somewhat challenging as well. And also, as Ranga talked about, data natives, and I was thinking that how could we apply some of that thinking to our own customer experience. So as title sponsors of this event, I'd like to, on behalf of Barclays and the team here, I'd like to thank, first of all of you for coming here. Ranga for your insightful talk, Abhishek for a really interesting peek into the world of automated lending, and Isaac for a really comprehensive presentation and talk through what we are doing at Barclays. I would like to thank ISME, our ecosystem partner, for being such a generous host. I'd also like to thank Datagiri guys. I think you have a fabulous community. We'd love to be more and more part of it. GreyAtom being our education partner for all of their help. And finally, our team, who's sitting at the back here, the team of organizers that you've got, and volunteers. So let's please all give them a big round of applause. Fantastic. Thank you guys, and please enjoy yourself for a round of networking and snacks and beverages. Thanks a lot.
Datagiri is successful because of you people. Thanks a lot for coming out to this event, and please stay tuned to our meetup page as well as your inboxes for more updates on future events. Let's open the floor for networking now, and for food and drink, head out to this exit, not to the back exits. This is the exit you should take if you're going to head out for food and drink. So that's about it. Thanks a lot, and a big applause for yourself.